Here's a short explanation on conditional and marginal distributions. First, we're going to look at the example problem from the last page on the Chapter 3 notes found on D2L. This shows a contingency table of sex and eye color. First, we're going to find the marginal distribution for gender. So we're going to be looking at the rows in this example, and we're going to be finding marginal distribution. So we're going to be looking at the row total, so 32 for males, divided by the total number of subjects. So we're going to take 32 and divide by 64. This gives us 0.5 or 50%. We can do the same here for females. So our marginal distribution for gender would be 0.5 for the males and 0.5 for the females, or 50% for each. If we wanted to look at the marginal distributions for eye color, we'd be looking at the column totals. So we're going to look at the column total for blue, 10 divided by, again, 64. And for brown, and for green or other. So this gives us our marginal distribution for eye color. Now we can also look at the conditional distribution. If we're going to find the conditional distribution for gender by eye color, we're going to be looking at the rows, the males and females. We're going to take the males for blue and divide by 32, which is the total for all the males. And for the brown, take 20 divided by 32. For the green or other, that's 6 divided by 32. These would be our conditional, this would be the conditional distribution for males by eye color. We found the conditional distribution for females by eye color. Again, we're looking at our rows, so we're going to take 4 divided by the row total of 32, 16 divided by the row total of 32, and 12. Again, these give us our conditional distribution for gender by eye color. Now, if we're going to find the conditional distribution for eye color by gender, we're going the opposite way. We're going to be looking at the columns. So we're going to be looking at the conditional distribution for blue by gender would be looking at 6 divided by 10, 4 divided by 10, and so on and so forth. We'll see with conditional distributions that when you're conditioning upon eye color, these values here would sum to 1 or to 100%. These also would sum to 1. And the same this way. These would sum to 1 now in the columns. Okay, let's go back and look at the problem that was given on the notes. Oops. Okay, I'm going to look at it over here on this other screen. So if we wanted to answer these questions, so let's look at what percentage of females are brown-eyed. So we're looking specifically at the females, so we're conditioning upon females and finding the number that are brown-eyed. So we're going to say the number of brown-eyed females is 16 out of the total number of females. So we're going to have 16 divided by 32, which equals 0.5 or 50%. So what percent of brown-eyed students are female? So now we're looking specifically at the brown-eyed students. We want to see how many are female. So we're going to look at 16 over 36. which equals 0.444 or 44%. Now we want to look at what percent of the students are brown-eyed females. So we're specifically looking at the brown-eyed females, so there's 16 of them, out of the total number of students, which is 64. So 16 divided by 64 gives us 0.25, or 25%. Now it's asking for the distribution of eye color. So we're going to look at the totals for blue, brown, and our other category out of the totals. So we're going to look at 10 divided by 64 equals 0.156 or 15.6%. 36 divided by 64, which equals 0.56. And then 18 divided by 64, which equals 0.28. Okay, that's our distribution of eye color. We wanted to look at the conditional distribution of eye color just for the males. Now we're conditioning on males. So we're going to look at just the row of males and look at each probability of them, of the eye color. So we're going to look at 6 divided by 32, which is 0.18. 20 divided by 32, which equals 0.625. And again, 6 divided by 32, which equals 0.18. Or it's actually 88. I'll change this one as well. All right, so here we want to compare the percent who are female among the blue-eyed students to the percent of all students are female. So we're going to specifically look at the percent who are female among the blue-eyed students. So we're looking at the blue-eyed students. So there's going to be 4 out of 10. 4 of them are female out of 10, which equals 0.4 or 40%. So what's the percent of all students are female? So we're looking at just the females. So we're looking at all the females, 32 divided by 64. This is 0.5. So this next question is asking, are they independent? So in the book, it tells us that when the distribution of one variable is the same for all categories of another, we can say that the variables are independent. So what do you think? Do you think that eye color and sex are independent? Well, it looks like less blue-eyed students, they're a little less likely to be female than overall the number of females. It looks like there's slightly a slight difference there. So it looks like they may not be independent based on these values of 0.4 and 0.5.